लाइव स्टार्ट हो गया शशांक? सही, बढ़िया। हाँ उज्जवल। आज कितने एक्सपेक्टेड है, मैं कितने स्टूडेंट ज्वाइन करेंगे?
20-25 आई गेस।
नेक्स्ट इवेंट वो लाइक एक्सपर्ट आने वाले सॉलिडिटी डेवलपर के, तो मैंने उन्हें बोला था कि मोर देन 80 स्टूडेंट होंगे।
हाँ लाइक अगर वो भी पहले से अगर कोई इवेंट में गए होंगे तो उनको आइडिया होगा कि क्या करते हैं और क्या होता है।
क्या?
लाइक उनको भी आइडिया होगा कि जो बोला जाता है वो तो नॉर्मली होता नहीं, अगर वो पहले भी कहीं गए होंगे तो।
हाँ ठीक है। स्लाइड देख लिया तुम?
Yeah, hello guys, I'm audible. Visual.
हाँ भैया।
Okay. Sasank, is everything okay? All the setup?
यस भैया।
Okay, nice. Okay, should I start or I should wait for 2 minutes more? Okay, just wait 1 minute more. So then I will start.
Okay, so very good afternoon to everyone. So myself Anand Kumar, and you might know me because I held several sessions for this bootcamp. So yeah, so just wrap up. So the this is the online summer blockchain bootcamp, and this is the session 4. So I already covered the blockchain part. So we had Pratik S. Patil from the
Okay,
Polygon Lab.
so
So
very good
if
afternoon
you
to
didn't attend this session, you must be attend. So now you can understand better. And after that, the season 2 is on the Bitcoin fundamental. So and after that, we already covered the Bitfinance with the Saurabh Paul from the assistant professor of IIT Bhilai. So in this session, we will focus on the Ethereum blockchain protocol. So am I audible to everyone?
yes, Bhaiya.
Okay, okay, okay. Thanks for confirming. So okay, let's start. So anyone know what is the Ethereum? You can just unmute or you can answering my question. Like unlike the Bitcoin is a peer-to-peer digital currency and the protocol. It's not a cryptocurrency. Just like here, Ethereum is not a cryptocurrency, but Ethereum is the world state computer. Like why I'm like talk here the world state computer, you can understand later. So yeah, the topic I would cover, like first the fundamental about the Ethereum protocol. What is Ethereum? What is the fundamental? How the Ethereum works, and the type of account. Like there are several type of account. In the case of Bitcoin, there is one type of account, and the data structure used to store the transaction and state. So here, like in Ethereum, we like the smart contract also has been introduced. So we will see how the smart contract uh, algorithm and the code is stored in the Ethereum blockchain. Then we will look on the blockchain validation and verification process, and then block creation process, and the final block difficulty. So this is like in-depth topics in the Ethereum blockchain protocol. We will see one by one. If anyone have any doubt or any question, just unmute your mic and just tell me. Okay, let's see like this. Ethereum put a computer on the blockchain. Okay, the like you can see these are the blockchain. We already know blockchain means the blockchain is connected with cryptographic algorithm that's very secure. So between the blockchain there is state, like this is called virtual machine state. So every blocks are updated by the help of Ethereum virtual machine. Okay, so this is called the world state computer. So each node represent a computer, and each block represent a state of current information. We will see what type of information is stored in the Ethereum blockchain and how the Ethereum blockchain is more useful than the Bitcoin blockchain.
okay.
Any
So
question
this
till
is
here? Anyone? Okay. So the Ethereum, the world state means, so let's assume this is the state n, and this is the state dash. You can say state n or state n plus one. So each state has been updated by the help of transaction. So whenever the transaction is happening in the mempool, the state has been changed. So the information about the account ether and the information of a smart contract has been stored in the particular block, and the value of a smart contract or any variable or any account updated by the help of transaction after the successful transaction. So you can say that each state has represent current information in the Ethereum blockchain. So let's say how many like details including the one block. So a particular block contain various information like time spent, on which time the block has been created, list of all transaction, hash of the current blockchain, hash of the parents block, and the uncle. What is the uncle? I will discuss later. Ujjwal, just inform me if I forgot to explain what is the uncle block.
Okay, भैया, okay.
Okay, miners address, difficulty, nonce, gas use, and the rewards. So when we study about the Bitcoin blockchain, Bitcoin blocks also covered a lot of information, but here is something new like uncles. What is the uncles and what is the nonce and what is the gas? I will explain in details what is gas exactly. So gas is a new concept in this Ethereum, and also uncles is a new concept, and also the difficulty. So unlike the Bitcoin, so the difficulty in the Bitcoin updated every 2016 block, but in case of Ethereum, difficulty of block updated after each uh, successful creating block. So for each block the difficulty will change in the Ethereum blockchain. Okay, and also when we talk about a particular transaction, so what information include in the transaction and what information required to successful transaction in the Ethereum blockchain. So in this case, the transaction will contain the sender address, the value, the gas price. I will I will uh, I will explain what is the gas price, the gas limit, what exactly the gas limit, value, the sent ether, what the value, data, anything, and the signature. Signature is again, I already covered the digital signature and the verification process in the Bitcoin tutorial. If you miss, you can see, you must see. After this, you can understand what is exactly. But in this tutorial, I want to cover the signature because I already covered. But in the case of Bitcoin, the Bitcoin contain only three field like from, to, and the value. But Ethereum is more advanced if I compare to Bitcoin. Okay, let's go ahead. Okay, so see here, this is the real time Ether. Like Ether can will show you real time transaction. So you can see the several field. Block height. Block height is the like number of block created before this block. Status is the finalized, and the time is spent. Like this block is already created 2,859 days ago. Transaction, zero transaction, and zero contact internal transaction in this block. So the Ethereum blockchain contain two types of transaction. One is the normal transaction, one is the account creation transaction. I will explain one by one. Mined by, this is the address of miner. Block reward. So in the case of Bitcoin, the block reward is halved by every 4 years, and the current reward is 3.125 Bitcoin. But in case of Ethereum, the current reward is only 3 Ether and plus the transaction fee. What is the uncle reward? I will explain again. And the difficulty of Ethereum blockchain update for each block, and this is the total difficulty. I will again explain what is the difficulty, what is the total difficulty, size in the bytes, gas use, and the gas limit is approx 3 million, and the extra data and the ether price. You can see here hash of the current block here, and this is the hash of the parent block, and SHA-3 uncle hash root. This is the state root, nonce, and some other details. So I will explain one by one. So the just concentrate on this tutorial because the Ethereum blockchain is much more complex than the Bitcoin. Okay, so let's start with the account creation. So uh, okay, so account creation. So there are two types of account. One is account, so you can control by your private key. Like Bitcoin contain this account. In case of Bitcoin, you can control your account through your private key. If you lost your private key, you can lose your all Bitcoin. But in case of Ethereum, there are total three types of account. One is called external owned account, means user can control by private key, and this account hold only the ETH balance. ETH is the native currency of Ethereum blockchain. And the second is a smart contract account that has executable code. So you can write any code or any logic and you can deploy over the Ethereum blockchain. This is called a smart contract account. Okay, and you can control the smart contract through your external owned account. And the third is a smart contract account. This is basically the combination of external on account plus a smart contract account. So you can say this is the programmable account. So you can control your account through code, not only the private key. The very like this is just introduced by EIP 4337 account abstraction. If you really want to go in depth, so you can go and read about EIP 4337. So the each account state contain nonce, balance, storage root, and code hash. You can understand these all things in the next session when we covered a smart contract part, how the smart contract created, how you can write a smart contract and deploy on the Ethereum blockchain, how the smart contract code has a store on the Ethereum blockchain. So these all are the things. For just now, you just need to understand there are three types of account in the Ethereum blockchain. First account you can control by your private key and it's contain only ETH balance. Second, this is the programmable account, and third is the combination of private key plus the programmable account. Okay, so let's understand the account in details. So let's say assume the green dot denote the your external on account, so you can control by your private key, and the orange balls represent the smart contract account. So a smart contracts include some logic code like C++, like Python. So you can write uh, your own logic and deploy over the Ethereum blockchain. So this the external on account that the green box contain only ETH balance or your private key. So you can sign any transaction with the help of your private key. But this is the smart contract account that contain only the logic code. Okay, so whenever you try to interact with your account, you can directly interact with two EOA account peer to peer. So you can just send some ETH to your friend direct by the help of your private key. So just like Bitcoin, you need to just sign your message with the help of private key and you can send your BTC to your friend. Okay, so just this is a simple things. You can create any wallet like MetaMask or anything. There's a lot of web wallet and that support the Ethereum blockchain, and you can send your ATH to your friend. The second method is call method on a contract. Whenever you deploy your smart contract, this ball contains some logic and you can call any function by the help of your external owned account. So this is the second method. And third, you can also send any transfer with the help of a smart contract account. You can just write. So by the help of one click, you can send your ETH to 5 friends or anything. Like if you win this race, the entire balance goes to your friend. So this is called the smart contract. We will see how we can write a smart contract in the next session. Okay.
They are,
Yes.
like, can you explain how a logic works with an example?
Okay. 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 So yeah. So in the chain reaction, I will explain how the logic works. Let's say you write some code in the smart contract like uh, if today is Tuesday, then call the another smart contract. If today is Wednesday, then direct send to some amount to my friend. So this you can write this type of contract with the help of Oracle. So this contract, the one smart contract call the another smart contract. This is also possible in the Ethereum blockchain because the Solidity is a turning completeness language. So this like support the for loop, while loop, and all the loop that support in C++ and the JavaScript. So you can also call some another external on account with the help of some other smart contract account. So you can, if you want to call this smart contract with the help of this, you can just write the address dot the function name. So you can call any function with the help of their smart contract address and the function name, like the class. So you like might know the object like oops in the C++. So you can call any function from like another yeah, what is the call in case class to, like whenever you try to call some function of other class, you can call like the class name dot the function name, just like there. Got it as well?
Yes, yes.
Okay, we will see exactly how we can write the smart contract and call another smart contract with the help of another smart contract, and also you can call directly with the help of like any external on account with the help of smart contract. So like for next season we have a expert of a smart contract, so they will teach you. This is called multi-signature via proxy contract. So you might heard multi-signature like whenever like you might like so for one transaction you need your sign, your parent sign, some of the sign. So if the transaction amount is very high or any suspicious, you can also create multi-signature a smart contract wallet. So for any transaction, we need multi people just for the security purpose. So if anyone compromise your one private key, then hacker can't steal your ETH, because for the transfer of ETH we need the three signature. So this is called the multi-signature via proxy contract. Proxy means you can upgrade your logic in the Ethereum blockchain, because the like smart contract is immutable. So if you deploy to a smart contract, you cannot change in the future. But using the proxy, you can change the logic, but not the smart contract. So what is exactly smart contract, or how you like where the smart contract come from, or how do you get the address of a smart contract? Okay, so in this transaction, you share the transaction contain the from sender address to the receiver address and the value. Okay, so these two field are very necessary if you want to transfer any amount to your friend or anyone. So if you want to send the ATH from your account to friend account, then the from contain your address and to contain your friend address. Okay, but anyhow, if you yeah, anyhow, if you like execute your transaction with empty to field, means the receiver address is empty, then the network will return you one address. This is called a smart contract address. Got it? Like, let me explain once time more. So whenever you try to send any ETH to your friend, then this transaction will contain your address, your friend address, and how much ETH you want to transfer. Then your ETH is transferred from your account to your friend account with the help of successful transaction. But anyhow, if you do transaction from your account to none, okay, then the Ethereum blockchain understand. So this user want a smart contract. Then this the like your code will be execute and deploy with the help of EVM. The network will return you one address. This is called a smart contract address. This is called a special transaction when the with the empty to field. Got it?
Yes, yes, yes.
Okay. Okay. So is there any question or any doubt till here?
deploy
What
with
is
the
account? How
call
many
the
types of
world state
account and
address. This is
how
called a
the
smart
all
contract
accounts work?
address.
Any question from any side? Okay. Okay. So let's see, like from now onward, the topic will be more technical. So you need to more concentrated on Okay, so first we see what is the Merkle tree. So you know, in the case of Bitcoin, every transaction is stored in like a specific data structure called Merkle tree. So the leaf node contains the transaction, and their parent is the hash of the transaction. Of like the this like this is the hash of their children transaction, right? So this is called a Merkle tree. So in the case of Bitcoin, the only thing need to store the transaction, but in the Ethereum that introduced the smart contracts, so they have to store a lot of data as well, just rather than the only transaction. So that's why we need optimized data structure. So in the Ethereum blockchain, there is a called Patricia tree. So what is exactly Patricia tree? I will explain. So first understand what is Merkle tree. Merkle tree nothing but this is the binary data structure. Okay, so they have the two children. Each parents have two children. So parents are, and the leaf node is contained all the transaction, and this is the hash of the transaction, and this is the hash of the hash of the transaction, and this is called Merkle root. This is the root of hash. Okay, so but in the Patricia tree, you can see, let's say I need to store test, toaster, toasting, slow, and slowly. So whenever if I try the Merkle tree, I just store all the variable in the leaf node and I can find the root. But there is some different rule. So you can just start with uh, comparing the first letter. So here is two different letter T and S. Then the node is two. Like one is started with T and the second one is S. So they like they traverse each alpha, each letter one by one. Then start with again comparing with the second letter in the T and in the S. So when you go ahead in the side of T, you got it. There is the two different letter E and O. So here you can again separate your nodes. Like this is come with O, and this is come with T. So after the T, there is no any uh, other comparable letter. So here is the store TEST. But if you come in the side of O, so there is again TOA, two letter, and after the A, the S is also same, the T is also same. Means this constant TOA means the name of branch, like uh, the OST. So here is the store TOST and ER. Like again, you come forward. Then here is the store toaster, and here is the store toasting, and here is the slowly, and here is the only slow. So slow will store it on this mode. Okay, got it? Everyone understand the Patricia tree data structure?
Yeah, what's the use? Like, how is it used in the blockchain?
Yeah, I will again explain. So here, so how I'm going to explain how this is used in the blockchain. So you can see you like this is the dummy account. So you can see here is the some account, there is the four account, and this is the ETH of some account. Like so this account contain 45 ETH, this account contain 1 way. Where is the smallest unit of ETH? Okay, and this account contain 1.1 ETH, and this account contain 0.12. But in ideal case, the account is 20 byte, 20 byte length. But this is a dummy account. I will explain how exactly to store the account versus amount in Merkle Patricia tree. So this is a Patricia tree, and the why are we are using Merkle? So the in the block contain the hash root of this root, hash of this root. That's why we are calling Merkle Patricia tree. So let's explain. Let me explain how exactly the Ethereum blockchain store your ETH and how it's connected to your account. Okay. So this is a basically a key value pair. So let's start with like this is called the extension node or root node. Okay. So the extension node contain again node. the work of extension node to like expand their node. Okay, and this is called branch node, and this is the leaf node. Here is the three type of node, not only two type, one type. So one is extension node, one is branch node, and one is leaf node. So let's start with the extension node. So you can just again compare with the first letter of all account. Can you see this account? Ujjwal?
Yeah.
Okay, okay. Just focus on my cursor. So like all account has started with A, you can see here, right? And after this is followed by 7. So so you can say the all account has started from A7. So A7 is like stored at here. Okay. After the A7, each account has a different numerical number. Okay, 17F7. So means we need to append three nodes after the A7. So this is the branch node. So one branch node start from one is 7, one is F. Okay, three types of numerical value. Okay, so the account started from one. So there is only one account. Look, okay, 17 followed by one. So means all the value stored at here, the remaining letter byte and their value. Okay, but in case of 7, there are two accounts, the account 2 and account 4. Okay, so you can see here 70 are the same. Means like 70 has stored at this node, but after the 70 d3, the difference is here like 37 and 97. Means we need to again append the two node, once start from 7 and like again in the 7. So if in the case of if a7f there is only one account, so the all values are stored at here in the key value pair, right? So how the Merkle Patricia tree works in blockchain? Got it? Uzzwal?
Yes, we are.
Okay, nice. Okay, so like in the case of Bitcoin, there is only one type of Merkle root tree that stores the transaction, and the transaction includes sender address, receiver address, and the amount. But in the case of Ethereum blockchain, there are the three types of Merkle Patricia tree. One is called straight root Merkle Patricia tree, the data structure used to store the current state of all account and a smart contract in key value pair, right? So this is the example of state root Merkle Patricia tree. It store your account versus amount and also smart contract. And this is called transaction root Merkle Patricia tree, used to store all transactions. Like you can see here is it store only the account versus amount, but the not the transaction. So just like this data structure, your transaction will store the key is sender account. Just you traverse one by one alphabetically, and the value is receiver account and the ETH. So store in this fashion. And third is receipt root Merkle Patricia tree, used to store receipt of all transactions, and like all transactions include the logs. Logs is called a way to connect frontend with the Ethereum blockchain. So the key value pair is the account is your key and the value is receipt. Receipt include a lot of things: logs, blooms, event, emit, fire, all those things. Like it also include the gas, how much gas used to trigger this transaction, and the logs value. Okay, I will show here like what's the right time.
Yeah.
Yes.
Uh, there is some wind sound coming like quite lightly from your side.
Okay, now it's okay.
Better, better.
Okay, okay. Can you see my like another browser?
Another browser like
Like I'm opening the Etherscan in other window.
no, it's still on the
Okay, okay.
PPT.
Let me share my entire screen. Okay, has my screen shared?
Yes, yes.
Okay, you can see this is the Ether scan, so you can see the real-time transaction. Can you see these things?
Yes, we are.
Okay, so let me explain one by one. So block height you already know. So this is the block number. So how much block already created before this block, and the status is finalized, and time spent is like this was created 1482 days ago, and this transaction include 173 transaction plus 9 contract internal transaction. Got it? So Ethereum blockchain contain two types of transaction. One is the normal transaction, one is the smart contract transaction. Okay, and mined by non-pool. Okay, Nanpool is the again the mining company like the Bitcoin. Block reward is 2.06 ETH plus the transaction fee at that time. Uncle rewards 0. I will explain. I will open the some block where the uncle rewards. Difficulty. So difficulty like this and the total difficulty. I will explain difficulty in details. But gas use. Okay. What is the gas use and the gas limit? So for in case of Ethereum blockchain, every transaction or every smart contract trigger by the help of Ethereum virtual machine. So for each transaction or for each operation, it will break down to bytes, and every byte has like every byte like for computing every byte we need to pay some gas. So it is already mentioned like add opcode contain like take 3 gas, multiply opcode take 5 gas. So uh, the based on their complexity we need to pay more and more gas. Okay, so in case of Bitcoin, the block limit is 1 megabyte. Okay, so we can measure byte. So what is the size of block, because it contains transactions, so we can measure easily. But in case of Ethereum blockchain, the block limit is 30 million gas. Means you can store only those all transaction, the value of all transaction is not more than 3 million. Okay, so it will break the opcode, and you can add by like you can add with the help of Ethereum virtual machine, and he will like inform you so you are exceeding this gas limit. so so this is the ideal gas limit, right? So at, at that time the gas limit was 8 million, but nowadays this is extend to 30 million. Okay, so if you like click on the transaction, okay, you can see this is the transaction hash, this is the method, this is the block, is from to value. This is the normal transaction, not much complex. Okay, so let's deep dive in the internal transaction. So what is a smart contract transaction? Okay, okay, so let's click like this is the parent has call from this address to this address, and the value is this. Okay, let me open any smart contract. Okay, let me open this transaction hash. So you can see this transaction contain the transaction hash, block, time spent again from uh, and interact with this contract. Let me open this contract. Okay, so you can see here the smart contract. I will show you how the smart contract look like on the Ethereum blockchain. Okay, you can see here some contract, right? Here is the function enable, here is the modifier, here is the function transfer ownership. So you can call each function by your external on account. Okay, the contract arc, the contract like similar to class. So the class contains several functions, and this is the smart contract logic. Okay, the smart contract on the Ethereum blockchain look like this. Okay, if you go to like read contract, so there are the two type of contract. Read contract will get you the value, and the write contract, so you can interact with any function of a smart contract just by calling and update your state. any variable. So this is the function name bid, this is the unpause, the create auction. So this is a smart contract on the Ethereum blockchain. Okay, and the size of this code again in the Ethereum is limit to the 24 kilobyte, so you cannot write more than 24 kilobyte uh, logic in one contract. Okay, yeah, so just what is the event and all those things. So when you see here, so like whenever with the you can say in simple word, with the help of event, any front-end developer can interact with smart contracts. So the Ethereum blockchain fired the image, so this transaction is happening. So it will again take some like gas, like 30,000 gas or the 50,000 gas. So the gas depends upon how much data you want to like fire for the like front end guys, not front end, like for the human readable, so any one can understand this event is fire with from the Ethereum network, means this transaction is successful. Okay, so this is also stored the like in the Merkle Patricia tree. Got it? Okay, can you see my the second slide, blockchain validation and verification process?
Yes, we are.
Yes. So let me deep dive how the block is created in Ethereum and how block is verified with the help of other client or with the help of other miners. Okay. So let's say this is your account. This is your account and you control your account with the help of private key. Let like understand one by one. So you can control or you can call any function. Like let me show you how you can call any function with the help of your account. Okay, so let's say you go to the right and you connect to web3. This will open your MetaMask. Okay, uh, why it's not working? Okay, okay. I think there is some problem with my MetaMask. Okay, so I will explain in the next session. So with the help of this is the my EOA wallet, my external account. So this wallet is controlled by my private key, so I can send any like I can sign any transaction with the help of private key. And you can call any function. You can just, this is the easy way to call, like just fill the data here and you can call any function. Okay, let me call the read function. Okay, there's the two type of function. One function will take your transaction fee, and these are the function will not take any transaction fee, because these are the only view mode function. The means the Ethereum network will just show you the value of your data and the variable. Okay, like honor is the current price. So you can just put the token ID, let's say 2. So what is the price of token ID for this contract? Execution reported. Okay, so you got the overall idea how exactly the smart contract look likes as well.
Yes, we are. Yes,
Okay, okay, we will see in depth how exactly we can deploy the smart contract on the Ethereum blockchain, and what is the variable and what is the data and what is the state. Okay, so let's focus on here. So this is your EOA account, external on account, means you can control this account with the help of your private key. And you can sign some transaction, like you sign some transaction and send to the network. Okay, there is the library ether.js, so you can send with the help of library. So the transaction is stored on the mempool. Mempool is the pool where all the unconfirmed transaction has been stored. Okay, the what is the work of miners? The miner will pick the transaction one by one. The miner, the basis of choosing transaction, like the miner will check uh, which user like want to pay more gas. those transaction will be chosen first, and this will validate means this will verify your account, your address, like your ETH balance, the smart contract which you like interacted, and like then after the verification and all those things, they broadcast in the network and mine a block like the this is like this tutorial like for Ethereum proof of work, but now the Ethereum has upgraded to proof of stake, but I will cover in this tutorial only proof of work algorithm. So like the Bitcoin, the miner need to again solve some cryptographic puzzle and need to verify. After the verification, after the creating block, again this broadcast to entire node, like node that present in the America, North America, and all over the world, and he will verify means they will check each transaction is really ideal, or is any transaction has been tampered. I already explained how the miner can see which transaction has been tampered with the help of digital signature and all those things. Then the block is mined and append in the state. Okay, so this is the linear block appended, like so the block is append in a linear fashion. So if the block is append in another block, so it's become not a linear, means it's become a branch. So the Bitcoin not allow any branch, so the branch block is again discarded and come to the main, and again uh, this block is going to mined and then append in the longest chain. बट इथीरियम के केस में ऐसा क्या होता है, इफ एनी ब्लॉक इज अपेंडेड not in the longest chain, in any other branch, this is called uncle branch, and the hash of that block is called uncle hash root. Got it?
एक बार और बता दीजिएगा भैया अंकल क्या।
ओके जब भी ब्लॉक लॉन्गेस्ट चेन में अपेंड होता है, दिस इज कॉल्ड द ब्लॉक, लाइक सिंपल ब्लॉक. एंड जब भी ऐसा कोई ब्लॉक लाइक विद द शॉर्ट ट्रांजेक्शन, लाइक सम लिटिल ट्रांजेक्शन, जो छोटे छोटे ट्रांजेक्शन का जो माइन करता है, जो माइनर मीन्स स्मॉल माइनर, लाइट मीडियम क्लाइंट, लाइक स्मॉल जो माइनर जो माइन करते हैं, जिसके पास ज़्यादा कंप्यूटेशन पावर नहीं होता है, तो वो क्या करते हैं, छोटा सा ब्लॉक माइन करके कहीं भी अपेंड कर देते, लाइक इस ब्लॉक में या फिर इस ब्लॉक में, कोई प्रीवियस ब्लॉक में अपेंड कर देते, नॉट द लेटेस्ट ब्लॉक. दैट ब्लॉक इज कॉल्ड uncle's block, not the parent block, right? The root of the uncle block is called uncle SHA3 root. Okay, and you know the reward of uncle block is very very like little award, like only the 0.5 ether, but the reward of parent block is like 3 ether. Okay, okay, let's break down again in depth. So what the trust trail? So the transaction, this is the like transaction, within the transaction how exactly broadcast. So if you sign any transaction, the miner works first validate your transaction, then verify gas. Gas means how much gas you pay to trigger transaction or successful any transaction. Okay, so whenever you try to interact with any smart contract function, तो based on their function complexity you need to pay more gas, because ऐसा होता है कि जो भी function के हैं, like in the case of C++, all the code is like converted to first the byte code, then it like compile. So वैसा यहाँ होता है same, like here the your code is like convert to the opcode byte code, and byte code is the combination of opcode, and each opcode has some gas. Okay, for each opcode you need to pay some gas based on their complexity. So they will check if you have really have enough gas to trigger this transaction, or if you don't have enough gas, your transaction will reverted and back to original state. Then execute transaction from the block. Consensus process means it's on the proof of work, means they will mine your block, then finalize your block and broadcast to everyone. The miner, the work of other miners to verify the blocks, and then together appended in the previous blocks and existing blocks. So this is called the set of blocks called blockchain. Okay, so what is the validation process, means how can other miners can verify if whether the received block is uh, like receive block is able to append in the existing blocks, or any data has been tampered. So he will check the syntax. Syntax means is the your transaction has follow the standard rule. The transaction signature means digital signature. The time is spent of the receive block is obviously the less than the current time. And the nonce of block. So in this case, again, the nonce is the two types. One is in the transaction and one is the block nonce. And the gas limit, like gas limit, he will check whether your block extend uh, is within the gas limit. The gas limit is 30 million nowadays. So if your block is extend over the 30 million, the other miners will discarded your block, and your block is not going to append. The sender account balance, he will verify the transaction. So the sender account has enough balance to transfer someone or not. And also the transaction signature and hash are also verified. So he will check the Merkle patriciatory hash root and all those things. This is the work of other miners. Okay, so is there any doubt, or any doubt to understand account and the block validation and process?
No, we are continue.
Okay, I think only core member are there now. Okay, no problem. Okay, block creation process. I already explain you how the blocks is created, but select looks in the point of client. Like, so whenever the transaction added in the block or in the mempool, okay, so he will check the double spending. Have you spent some same amount in the two different address or not, or any invalid account? ओके, ऑल दोस थिंग। सो कोई ऐसा तो नहीं कि जिसने प्राइवेट की टेम्पर्ड करके दे विल क्रिएट डिजिटल सिग्नेचर एंड ब्रॉडकास्ट टू नेटवर्क। सो दिस इज द वर्क ऑफ माइनर। then like in the validation process, miner will check all those things. Okay, and then pool of unconfirmed transaction called mempool. Okay, like in the Bitcoin there is also a mempool. Mempool contain all the unconfirmed transaction. So miner will pick the transaction and they set the transaction and mine the block with the, there are some again cryptographic puzzle. The miner need to solve this puzzle and find the nonce value. And if you are the winner, this is the race problem. Like whoever the mine first, the block is going to append their block. Like their block will be appended first. Okay, solve the block broadcast, a new block verified by the other miners. And if the transaction are confirmed, they append in the new block, like existing blockchain. Okay, if there is any tamper data, the other miners will discard, and your all the transactions will again go to the mempool. Okay, okay, this is the block difficulty. बिटकॉइन के केस में कैसा होता है, द डिफिकल्टी ऑफ बिटकॉइन विल चेंज after the 2016 blocks mined. But in case of Ethereum, your block difficulty equals to parent block difficulty plus parent blocks difficulty divided by 2018 into max of 1 minus block time, the time of block mine, and by 10 comma 99. This is the equation of finding block difficulty, and this is called difficulty bomb. Difficulty, the Ethereum Foundation has introduced difficulty bomb because over the time the difficulty of Ethereum will high and high. So it is very difficult to mine Ethereum block after the 10 year. That's why they have plan to change their consensus algorithm from proof of work to proof of stake mechanism. That's why they introduced the difficulty bomb. So this bomb is this is like uh, but difficulty bomb, the difficulty of Ethereum uh, change how can I say, unfortunately highly. And the total difficulty is called this. This is the a set of total difficulty. means total difficulty contain the difficulty bomb and the normal difficulty. Okay, visual.
Okay.
Okay, transaction fee. So in case of Bitcoin, we need to give transaction fee only for transactions from BTC from your account to your friend account or any other. But in case of Ethereum, uh, you can have pay the transaction fee in three cases. First, the operation computation. Operation computation, whenever you like deploy your contract or you deploy your smart contract on the Ethereum blockchain, or the whenever you interact with some function of contract, so this will like compute your complexity, and the based on their function complexity you need to pay the transaction fee. Or the message call, you can also send some message, not some ether, you can send also some message from one account to other account. So based on the bytes of your message you need to pay the ATH like gas. So why we need to pay gas for each operation? Because like टू प्रिवेंट डिनाइल ऑफ सर्विस अटैक, नहीं तो ऐसा होता कि कोई भी आता और एक लूप लगा देता जीरो टू इनफाइनाइट, और सारा जो ईवीएम है वो लाइक कोलैप्स कर जाता, मीन्स जो भी हो ब्लास्ट ऐसा होता कि इनफाइनाइट लूप तक चल रहा है एक ही ब्लॉक, तो वो कोई प्रोसेस ही नहीं हो पाता। इसलिए दे इंट्रोड्यूस द गैस कॉन्सेप्ट। सो फॉर ईच ऑपरेशन यू नीड टू पे गैस। तो अब ऐसा होता है कि लाइक दे हैव सर्टेन लिमिटेशन 30 मिलियन गैस, उसके बाद वो जो जो भी प्रोग्राम है वो ऑटोमेटिक स्टॉप हो जाएगा। okay? And for message call and the contact creation means deployment, and the for increase the use of memory, the EVM has also some memory storage stack and all those things. So whenever you write any function that use any memory, so for like whenever you use any memory you need to pay gas. So if you want to expand your memory you need to pay more gas. Okay, so gas is the fundamental network cost until converted to and from ether as need to complete the transaction while it is sent. Okay, let me show how the opcode look like and the how the gas. Where is my okay? Can you see this page? Okay, okay. लेट मी एक्सप्लेन लाइक दिस। जैसे तुमने कोई फंक्शन बनाया कि फंक्शन ए will return you, like function a will contain like take two field a and b and it will return by add their value. Okay, so for this the add, like the add function, like first converted to bytecode, and the bytecode include add opcode. The add opcode take three gas. The two input, it will take two input a and b and will return you a plus b value. So this function will take three gas, so you need to pay three gas to successful add function. Okay, so these are the long like opcode, and each opcode had some gas. Okay, so based on complexity, like I can compare, obviously multiply any like multiply of two number is more complex than add of like adding two number. So for multiply opcode it took five gas, but add opcode it took only three gas. So because the multiply operation is more complex than addition, so that's why we take five gas. Got it? So in the yellow paper, it like has mentioned in the very deeply which opcode will take how much gas. Okay, this is the Ethereum blockchain. Okay, now only there are only core member.
No, yeah, like there are two members out of
What?
club. There are two people out of club.
Okay, no problem. Like now, can you understand what exactly the Ethereum blockchain, and like तुम्हारा concept clear हुआ? What you know before and what is the
हाँ,
knowledge you have now? Okay, अगर कुछ question है then you can ask. Athar, Mithul, anyone? Okay, Sasank, stop the live. And for core member, like we have something to discuss, so don't leave the meet.
हाँ भैया अभी सिर्फ 4 members हैं.
Okay, okay. Sasank,